Hey, welcome back, 7th grade. We're going to jump back into problem 4.4 today, which is going to be writing equations for linear relationships. We practiced a lot with looking at equations. We started looking at graphs and tables. Now we start looking at creating the equations from written scenarios and pulling out information that helps us with slope, that helps us with y-intercepts, and seeing how that can help us answer other questions too. So this is the last problem in this entire book, so it's going to be a lot for us to process through. So if you need to watch this video multiple times, totally get it. Just make sure you're working through it. And yeah, all right, let's jump in. All right, 4.4. Throughout this unit, you've learned several ways to model linear relationships. You've also learned ways to move back and forth between tables, graphs, and equations to solve problems. The next problem pulls some of the ideas together. So here we go. First thing. Question A. Today is Chantal's birthday. Her grandfather gave her some money as a birthday gift. Chantal plans to put her birthday money in a safe place and add part of her allowance to it each week. Her sister Shanice wants to know how much her grandfather gave her and how much of her allowance she is planning to save each week. As usual, Chantal does not answer her sister directly. Instead, she wants her to figure out the answer for herself. And here are the clues. After 5 weeks, I will have saved a total of $175. After 8 weeks, I will have saved $190. So, how much of her allowance is Chantal planning to save each week? How much birthday money did Chantal's grandfather give her? And we're writing an equation for the total money. A, Chantal will give her after n weeks, or have after n weeks. What information do the y-intercept and coefficient represent? All right, so here we go. Here's what we know. We know after 5 weeks, that's going to give us $175. And after 8 weeks, she's going to have $190. So what we need to do first is think about what she's saving per week. Now, what I think would be a good way to do is see this as potential, like 2 different ordered pairs. So if I look specifically at something like 5 and 175, and then 8 and 190, I can kind of look at what's happening here in this process. Now, that's one way to look at it and begin to do the slope formula. We could also see it as x and y values like we saw before. So I've got my x and my y. If I look at this way, I've got my 5 is going to be 175. And then I've got my 8 and 190. I could look at that there and see what the change is going on between them. So let's try this way first, look at this. So if I go for the change of y, remember the change of y, we would have here, this change is going to be, this will be a plus 15. So that's going to be a 15 for that. And the change of x is going to be a plus 3. So can I simplify this down to like a unit rate? 15 over 3, that divides, it ends up being like a 5 over 1. So that seems like this x is going to be the y would be the weeks, or the money, and then the time. It's got money and the weeks. So it looks as though what she's doing is she's saving $5 per week there. Hopefully that makes sense. That would be one way we could do that. So all we did is we looked for the change of the y value over the change of the x value to get that $5 per week. Number 2, how much birthday money did Chantal's grandfather give her? Okay, so this is kind of a work backwards process. So we got to think about this. After 5 weeks going by, we knew we had five weeks, and every time she had $5 per week. So if I did 5 times that $5, that would give me $25. This is what she saved, okay? And so then we had to think about, well, what did she start with? Well, if she has $175 at 5 weeks, I could actually do 175 minus that 25, and I would get $150. Now that could be one way to approach it, but we're gonna work this out in another way just to be sure. So let's go back to our table of values that we had before, and I need to know what we had. So at 0 weeks when she first got it, 1 week, 2 weeks, 3 weeks, 4 weeks, and 5. And that means we are at 175 But remember, it's $5 per week. So if we work backwards here, it'd be -5, which would be 170, -5, which would be 165, -5, which would be 155. Oops, sorry, 160, sorry. -5, which would be 155, and then -5 would be 150. And so there it is. Upon 0 weeks going by, she had saved $150. So there's multiple ways that we can go through this and see how that. All right, part 3. Write an equation for total amount of money. A, Chantel will have saved after n weeks. Okay, what information do the y-intercept and coefficient of the variable n represent in this context? All right, so 2 things that we need to make sure we have. First of all, this rate of $5 per week is important. And then this amount at the start is important. So what we have here is this, that rate is gonna be our new term. That's our slope. So we need to use that for our equation. And remember, whenever the value of x equals 0, that's going to be our y-intercept. So when we're dealing with this here, we're going to actually go in and write this as the equation. They want A for the amount of money, and we're going to be looking at n for our variable. So she's going to be doing, first of all, $5 per week plus what she had at the beginning, which is going to be 150. And so you can see this coefficient within is the $5 per week, and then this $150 is the y-intercept, what you started with when no time had passed. All right, part B. In the United States, temperature is measured using Fahrenheit scale. Some countries, such as Canada, use the Celsius temperature scale. In cities near the border of these 2 countries, weather forecasts present the temperature using both scales. The relationship between degrees Fahrenheit and degrees Celsius is linear. That means we can find a y-intercept and a slope. 2 important reference points for this relationship are water freezes at 0 degrees, which is 2 degrees Fahrenheit. Sorry, 0 degrees Celsius, which is 32 degrees Fahrenheit. And water boils at 100 degrees Celsius, which is 212 degrees Fahrenheit. So first thing, number 1, use this information to write an equation relating degrees Fahrenheit and degrees Celsius. We're going to treat this one just like we did before, but we're going to have it like be a table of values, have like an x and a y. So we have 0 for Celsius, 32 for Fahrenheit. So 0 and 32. And then we have water boiling is 100 degrees Celsius and 212. So 100 over here and 212 here. Now, if you remember, we could actually go in and do something very similar that we did up here, where we looked at the ordered pairs and looked for the change of the y over the change of x. So let's talk about this as our x value and our y value. So the same process that we just went through. So let's try that out. So my change of y from here to here, that's a tough one to know right on top of my head. But if I do 212 minus 32, I get 0 and then 8, so 180. Okay, so 180 comes in there. So that's my change of y over the change of x is going to be 100, right? So I would have a 180 over 100. That's going to be our rate. Now, can we simplify that down? Let's take a look. Well, first of all, remember our little trick? We cancel out those zeros. So now I've got 18 over 10. Can I simplify that even more? I can divide both of these by 2, which is going to give me a 9 over 5. So this is our slope right there. That's the slope that we have. Okay, so in this case, that's our slope. And then remember, we need to have a y-intercept. And our y-intercept is always going to be where this x value is 0. So from there, what we could do is we can sort out and understand this process. So remember the overall structure of our equation was looking like this: y equals mx plus b, where our x value comes over here and our y is over here. That rate is in the m and the b is our y-intercept. So I'm going to actually have the f value here is going to be Fahrenheit is equal to our rate is going to be 9/5 or 9 over 5 c, and then our y-intercept is going to be that plus 32, and that is our equation right there. All right, B2. How did you find the y-intercept? What does the y-intercept tell you about the situation? Well, this is actually pretty straightforward for us. What we know is that in this case, we treated the Celsius as the X term and the Fahrenheit as the Y term. And whenever something is 0 or X value is 0, that 32 is how that y-intercept would come into play. So that's how we would find it. We use Celsius equals 0 degrees, and that means Fahrenheit equals 32 degrees. That's how we found that out. All right, number 3. A news website uses the image below to display the weather forecast. However, some of the temperatures are missing. Use your equation from part 1 to find the missing temperatures. Okay, so now at this point you can see when they give us the degrees Celsius, we can work way in there and figure that out. When we don't have degrees Celsius, we have to plug in the 63 and sort that as we go. So let's try that out here. All right, for Monday, 13 degrees Celsius is how much degrees Fahrenheit? Well, we bring that same formula over that we just had. Fahrenheit equals 9/5 C plus 32. We take that 13 degrees and we put it in here. So what I'll do is I'll do 9/5 times 13/1. There's no cross canceling going on, so I need to do that. So I'll do 13 times 9. It's going to be 27. It's going to be 11. So I have a 117 over 5. That means I need to do 117 divided by 5. And so in this case, what we're doing is we're going in and we're going to be dividing this way. So it's going to be a 2. We get 10. We'll bring down the 17. It's going to go in 3 times. And that's going to end up being 15, 2 decimal point, come down. So that's going to be 23.4. So that's what this is right here, 23.4, then plus the 32. Okay. So when I do that, I have 32 plus 23.4. Sorry, my dog is flipping out. 4 here, 5 here, 5 here. All right, back to our regularly scheduled plan without a freaking out dog. 32 plus 23.4 ends up being about 55.4. Now we wouldn't round up, so it ends up being that would be, Fahrenheit would be equal to 55 degrees right there for Monday. All right, Tuesday, it's going to be Celsius 14 degrees. So again, 14 degrees Celsius is how many degrees Fahrenheit? All right, so same process we have here. Fahrenheit is equal to 9/5 C plus 32. So what we're going to do here is put 14 in there. So 9/5 times 14 plus 32. So over here we'll do that. 9/5 times 14 over 1. So in this case, we're going to be multiplying straight across again. So 14 times 9, this is going to be 36. 9, 10, and it's going to be 12, so 126 over 5. So 126 over 5. And I'll do 126 divided by 5. Going to be time, because we're going 2 times. Bring down the 6, going to be a 5. So 25.2. So it's going to be 25.2 plus 32 for degrees Fahrenheit, which in this case will be 32 plus 25.2, which will be a 0.27 and 5. So Fahrenheit degrees will be 57 degrees in that case.